Don't be shy. That is the learning of the afternoon. It is 3 p.m. 3 p.m. in the beautiful North Pike. It's sunny outside and I smell spring. I smell spring. Today we are connecting end users with photonic solutions for advanced beauty. Companies like Colgate or L'Oreal. Why? Because you are worth it. I always wanted to say this. On Monday 19th of April at 3 p.m., we are going to return to connecting photonics with the cosmetics and beauty industries. Because a few months ago, we had fascinating conversations with Veronica Marek and Benjamin Askenazi. They are both photonics researchers for L'Oreal, that ultra-famous French cosmetics empire. They want to better understand how their products interact with body cells and the short and long-term effects of the active components. But on April 19th, I want to investigate a new direction at L'Oreal called augmented beauty. It's where data science meets applied and digital optics. I think there are many different steps where EPIC members are supremely qualified to get involved. And here it gets extremely interesting. We have realized that there is a clear overlap between the interests of the cosmetic sector and medical research. They both need improved skin characterization, and they both see the advantages of two key photonic technologies, hyperspectral imaging and optical coherence tomography. So we will welcome in the room the technology of DAMAE, combining the advantages of OCT and confocal microscopy, giving both penetration depth as well as high-resolution cell imaging. Let's ask them the epic question. Last year at CES in Las Vegas, I was amazed by Colgate. Yes, the toothpaste brand, they will be in the room. Do you know that at CES 2020, they presented the first smart toothbrush which added optical sensors to detect early buildup of plaque?
So you have optical sensors that are here in the head. And what's amazing about these is that they actually emit blue lights. There's a substance known as porphyrin fluoresces back red light. Those optical sensors are able to see that red light.
I really want one of those. I get goosebumps just imagining what's next. There is no time now to go into more detail, but we will have 2 hours on Monday, April 19th at exactly 3 p.m. Sign up now to propose your technology to end users in our Zoom room. Or watch live or later with the rest of the world on our epic YouTube channel. I'll try to look my best. And I did my very best to look my best. This is the result. Thank you so much. The end users today is what's driving this industry. Our EPIC members want to connect with end users. Having you in the room is priceless. My eternal gratitude from us, EPIC, but also from our 700. Last week we became the largest, we are already the largest association. We became the association with 700 photonic companies, but I keep saying this and will never change. For as long as the technical team works at EPIC, we will always know every company individually. Every company individually, no matter if there is 700 or 7,000, we'll always know every company individually. That is what makes EPIC really, truly epic. My name is Jose Pozo, and I speak on behalf of a fantastic team, people who dedicate their life to the photonics industry with technical and with marketing backgrounds, half of them with a PhD, and one of them you know very well, Dr. Elena Beletkaia, who is here with me. We organize events, we provide access to a network, we help you raise capital, we have the biggest website to find a job in photonics, jobsinphotonics.com, and of course, every EPIC member has a long list of market reports available for them for free because that's what they join EPIC to be part of the largest association of photonics. Today is our second chapter of the season 4 of the online technology meetings. We are very excited about this season. I'm very excited about today for the cosmetic and beauty industry. But write down, those of you in the medical market, write down the 10th of May for urology, and write down also the 14th of June on medical device for surgical procedures. Those meetings, in the same way as this one, we are doing our way. We are doing our best to bring key end users, system integrators who want your technology in the room to answer the epic question. And also this Friday, we finish our first season of the online quantum technology meetings. What a season it has been. And I think we saved the best for the last. So tune in on Friday, 23rd of April for our online quantum technology meeting. But today is about photonics for cosmetic and beauty industry. First of all, I would like to thank our media partner, AZO Network. Thank you so much for the fantastic job you are doing promoting our events to all the world. But also, I would like to say, without the support of these sponsors, this meeting wouldn't be possible. So thank you, our sponsors today, OFS, a Furukawa company who develops specialty and telecom fiber. You're looking for any specialized fiber for medical or for any high-end solution, or you're looking for telecom fiber, OFS is your partner. Thank you for sponsoring today. And one of the companies we carry in our heart very deeply, RiverD Diagnostic, a success story of the European ecosystem. We are talking about a company that provides in vivo skin analysis by confocal Raman spectroscopy, which already has been widely adopted to the cosmetic and personal care industry. Actually, they recently introduced a quantitative analysis of skin penetration of products applied to the skin. We're going to hear a little bit from them later. Thank you so much, RiverD Diagnostic, for being in Epic. You're truly fantastic. And also truly fantastic is the epic medical expert and dear friend, Dr. Elena Beletkaia. Thank you for the great job you're doing putting this fantastic meeting together. What's going to happen in the next 2 hours?
Well, I hope in the next 2 hours, everybody will be as equally amazed as me with all the developments and all the technologies that will be presented during the meeting from L'Oreal, DAMAE Medical, Colgate, Quanta system, OFS. So we put it all together, but even more, it's interesting to see how diverse is the supply chain of photonics companies which come together to work on developing even further, pushing to the next level the beauty industry and the cosmetics to make it better. And it goes anywhere from lasers to optics to specialty fiber to power supplies and materials, spectroscopy, black coating. And there are so many different components which system integrators can put together and end users can tell us what do we need to make it work better. So I'm really just looking forward to these 2 hours and all the presentations and discussions coming up.
Thank you so much, Elena. This slide only corresponds to the companies who registered for the meeting today. So you are an Epic member and you miss your logo here. You forgot to register for this meeting. Don't let it happen again. Register as soon as possible for the upcoming online meetings. And all of you already know this. This meeting is live streaming YouTube. That's why you have to look fantastic. Hello, YouTubers. Thank you so much for joining. If you have any question, please post it in the chat after the meeting. If you want to get in touch with any of the participants today, drop me an email, jose.pozo@epic-azo.com. We'll check if you have actually a win-win collaboration opportunity, and if so, I will make the introduction because this is what it's all about. And this is of course also valid with the people with me here in the Zoom room. Use the internal chat. We have a private chat here. Use it, abuse it. During the presentations, I don't mind seeing you typing because I really want for you to get to know each other and do business. Let's do business. Let's do business today. I think the best way to start doing business is to go with the company that for us started this market. It was 1.5 months ago when we met L'Oreal in the Photonics Plus event, and we were amazed. I never received so much positive feedback from Epic members about collaboration opportunities with L'Oreal. For me, that was fantastic. It was truly fantastic. We decided to have an online meetings with them as the opening keynote speaker, and today we made that dream come true. Thank you so much, Veronica Marek and Benjamin Askenazi, for making this beautiful dream come true. The floor and the attention of everyone goes to the iconic L'Oreal. The floor is yours. We have a problem, which is you're muted, and I have a Mac to celebrate such event. So please unmute yourself so we can hear your voice. Yes.
Yes, I should be unmuted.
No, you are.
Can you still see my screen?
We see you, and you look fantastic, but we cannot see your slides.
Okay, coming right up.
I'm sure we'll make it. So bottom of the, yes, it is happening. I see myself and I do look great, so thanks for that. Yes, and then
and now
yes.
we should be good. Perfect. So thanks a lot for the nice introduction, Jose, and thanks for all the epic team for the opportunity to come and speak to you today. So I'm Benjamin Askenazi. I'm a team manager of the Applied and Digital Optics team here at L'Oréal, and today with Veronika Marek, my colleague, we'll be guiding through you through the activities that we do in our team and discussing about them. So when we think about beauty generally, we think about the amazing products that you can find on the market, or you can think about our amazing beauty expert and sales team. But most rarely, people think about devices that are becoming a thing in beauty, and it's why we call the beauty tech industry and beauty tech market. And often rarer, people think about photonics, but that's what we're here to discuss today. And to see how photonics and high-end optical engineering can help us to build personalization and amazing point-of-sale experiences. So what we do in our team, we work mostly, as I said, on personalization, and this goes through several technological bricks. So first, we need to measure things to scan or the skin, the hair, or the products in the lab. Then we need to do something with the data that we just acquired. And so we have a modeling, which can be physical or statistical modeling in order to exploit those data and to do something with those. And finally, we need to make the product real. So when we do some personalization on point of sale, for example, we can actually make the product. But other times it will be make it real enough so that the consumer can imagine it. So for example, augmented reality, virtual reality to do some virtual try on. So now I'll give you a few examples about the different technology that we like to use on those different three different bricks. So so first the diagnosis. So a lot of the things that we do are in need of spectroscopy, be it for color measurement and appearance measurement, or more, let's say, chemical-oriented spectroscopy with Raman, IR spectroscopy, or LIBS spectroscopy, for example. We do also imaging. So you can see devices behind me. So you have this one, the Lancôme skin screen. And it's an RGB full-face device, but we also are interested into multispectral and 3D imaging, mostly in devices with controlled illuminance. So we have a lot of information about the picture that we are taking. But we are also interested in smartphone imaging, because even though the configuration is not as much controlled, it's most free. It's a large source of data, and that's what consumers have in their homes. So everything that we can do on smartphones, we will gladly do it. And finally, a lot of other different things. We look at bringing some monitoring in home or in point of sale. So we can have UV sensors or environmental sensors to track people's activity, environment, and everything that can impact their skin, or biomarker diagnosis on point of sale, to give you just a few examples of those. Moving on to the modeling and algorithm side of our activities. So we need to be able to model properly the skin and the hair if we want to be able to understand how product will interact with them. So here you see some an extract of a paper from hair simulation that shows the optical path inside one fiber of hair, and the result that you get according to the eumelanin and pheomelanin concentration that you can have in your hair. But basically, skin and hair modeling are very important for activities. Then we also have a bit of activity on color science and color modeling, because if we want to personalize colored products, which is most of what we do, we need to be able to predict the composition, the color of a mix. And for example, you see on the bottom, it's Le Teint Particulier machine, so it's personalization of foundation. And you can see the mix of white, yellow, red, and black that will give you the very accurate skin color that we want to produce. And by the way, you have two of those machines just behind me, previous versions of the machines. And on the top of that, you have Pozo, which is the same for lipsticks, but again, same idea. We also work a lot on computer vision because there are a lot of things that we want to be able to estimate on pictures. As I said, we want to be able to use smartphones as always when it's possible. And for example, we have trained a model to be able to give a color measurement in the same color space as a color device would do. And we also want to be able to analyze, for example, the cosmetic signs and aging signs on the face in different situations. So that's a big part of the activity of the team. And more generally, AI. So even if AI is a part of what we do in computer vision, for example, you have a picture here of a person with only few measurements that give you an idea of the skin color. So going from this information to recommend the right product is not trivial and requires a bit of modeling. And finally, what do we work on rendering? So I've said it in the introduction, we work on augmented reality. We even bought a company that's called Modiface that specialized in those kind of technologies and apps. So the idea here is to be able to render the color and the appearance of hair or makeup products. But there are other ways to do augmented reality than just changing the picture on your smartphone screen. For example, you have light projection mapping, which offers a different feeling of the makeup as you can see it on yourself, and you can as you don't go through a screen, you can see very small differences much better than you would on a screen. So that's a completely different user experience. So for different usage. So again, for light projection mapping, we can do makeup, we can do hair, and here you have Alexandros in my team at a conference showing the photo booth with the mirror that we created. We can also work on avatarization. So augmented reality is one thing, virtual reality is another, and you can imagine some things that are easier to explain in virtual reality than they are in augmented reality. For example, haircut is a good example of that, because it's quite difficult to change a picture, a video stream of you in your smartphone to change the haircut, but to create an avatar of yourself and to have a 3D haircut around it is fairly feasible. And finally, we need, as I said, when we can, to make the product real and to dispense it. So again, we discussed the example of Le Teint Particulier and Perso. And you also have here an example with SkinCeutical. Again, the machine is just behind me, which is a personalization of serums at derms in the derm office. So yeah, so that's a very brief overview of everything that we do in the team, and that's all I wanted to share with you today. Thanks for your attention.
Thank you so much for the sharing. There's so many interesting things and so much of great technology in there, I'm sure. And yeah, I guess people are speechless for the moment, but very soon there will be kilometers of questions popping up. But maybe first question, why did you turn off your camera after such a great presentation? Keep showing yourself.
I did not, a mistake. Yeah, my bad.
Okay, well, but now we see your beautiful face again, and we already have a question in the chat. So Panagiotis from Alpes Lasers, would you like to ask a question?
Sure.
And don't forget to unmute yourself.
Yes. So my question is, what are the spectroscopy applications that you focus on? And the reason I'm asking is because our lasers are primarily used for spectroscopy applications, and we also have a few projects on IR, mid-IR imaging, where we're doing active illumination with tunable lasers, and we get like hyperspectral images with much better, not resolution, but let's say spectral coverage, I'd say. So I was just wondering about the hyperspectral imaging applications, but mostly on the spectroscopy side. I guess it's for quality control, but if you can tell us a bit more about that, substances or spectral regions that you investigate, that'd be great.
Well, I'm sure that there would be some applications in quality control. That's not what we focus on in our team. What we would like to be able to do with this is to diagnose something that is hardly quantifiable without this kind of technology. So, for example, if we can have access to content of water or some kind of lipids or specifications of the state of collagen or things like this, that could be very interesting for us.
Maybe to give you a precise example, what has already been done actually with River ID, a company who is present here today. It was about Raman spectroscopy, and it was about everything related to hydration, not only water but also natural moisturizing factors, lactate, etc., etc.
And since we are already having a short introduction of River D, Gerwin, would you maybe say a few more words and also what Raman spectroscopy is capable of and what River D is offering? And don't forget to unmute yourself.
Sure. Can I show one slide?
Yeah, sure.
So what we have focused on in the last few years is to actually quantify, if you put something on the skin, how much of a product actually penetrates into the skin, how fast, how long it stays there, and how much actually permeates through the skin. So it becomes also available in the living skin and in systemically even. Now, as everybody knows, the skin is the barrier between the outside world and the body. But it might surprise you to know that until now, there was actually no technique that could do this non-invasively. So actually quantify how much in milligrams per milliliter or in micrograms per square centimeter goes into the skin. And this is what we've cracked. So we've published this about 2 years ago, and we've turned it into a product. And I think this should be very interesting, both for the personal care and cosmetics industry, as well as for the pharmaceutical industry. So this is what I wanted to show. I hope, so we're a few steps further than only measuring hydration and lipids and NMF. I think this should be, I hope it will be of interest, but it should be, I would say. Thank you.
It sounds to me like it should be of a lot of interest. And in the meantime, we have more interesting questions coming up. We have from Michael Onderwald from TNO. Do you want to share your question? Michael, don't forget to unmute yourself.
Yeah, I hope you hear me now.
Yes, very well.
Okay. Yeah, could you show your email address again? I work at TNO, which is a research and development organization in the Netherlands. And we do a lot of tissue optics modeling with Monte Carlo simulations. And I would like to discuss with you whether there's interesting fields to collaborate on.
Sure thing.
Great, we have already collaborations happening right here, right now. That is really great. Yeah, please use the chat. You also can have private conversations in the chat. And while everybody is thinking of their next question, I will have one of my own. While I was, let's say, preparing and reading on the topic for this meeting, I did meet a lot of conversations also about measuring the skin tone to choose the best cosmetics. So not only in terms of cream and penetration to the skin, but also for the best color. Do you also work in that dimension? Is that also something of your interest?
So yes, it is, for a fact that it's the best way to advise the best product to a large amount of people, instead of make it attuned especially for them, is already to guide them through the offer, which can be very massive, and sometimes it's difficult to find the right product even if it exists. So yes, it has a very strong interest. And we used to have a point of sale system, which is called a shade finder, and that that finds your shade of a foundation for Lancôme brand on the counter. And now we went and brought this technology online, and we have a few brands already that are deploying it, and it's going to be a big part of the activity of the brands. Our digital is growing these days due to the COVID situation.
Okay, fantastic. So yeah, I'm also looking forward to the point when it will become completely available, maybe in the store when I'm trying to choose it, and then to have a little device. But also, since we are talking a lot about augmented reality and integration, so do you also see some spectroscopy to be integrated, let's say, in mobile phone, and then combining those together with your applications?
Yes, any device that can be brought home to the consumer through smartphones is very useful for us. So depth camera can be very useful, and spectroscopy on smartphones can be very useful for us, indeed.
Okay, I'm sure that there is at least one person in the room who has more questions to you, and you all know him
How
very
well
well.
does he know me? Oh my God, Benjamin, Veronica, that was truly great to have you here, and we have so much stuff for you, so many questions. I'm gonna go fast because I could stay with you for several hours. But first, we have a Sumitomo Electric in YouTube asking already. They really want to know what wavelength do you use for detecting moisture in the screen, in the skin.
Moisture is
What
mostly
is
related to near infrared, so that's the easiest thing. Then you want to detect water. But another question is how do you define what hydration means? So that's why I talked previously more about natural moisturizing factors or lactate or whatever, because one thing is how much water you have in your skin. Another thing, what's the rate of evaporation? What are other molecules that could bind it? So there are several things, several molecules I already have in mind, but that's something that's of much of our interest. So if anybody here in the room have any other ideas how to evaluate skin hydration or more maybe feeling related to hydration, we will be very curious to know.
Anybody in the room who has ideas to measure skin hydration? This is not an exam.
I will
now
also
or later.
add. Yeah, I will also add that it's when we talk about hydration in cosmetics, we think about the very external layers of the skin, where it's not as in the medical field, where you're looking basically at the whole derm and try to measure the hydration here. So being able to focus only on the few micrometers of the top of the skin is very important.
On that, I actually do have a company that I think I introduced you already, but if not, well, my job was not yet done. Dieter from Wasatch Photonics, because every time we talk about monitoring sensors, I always talk to him. They already know you because I made the intro, but anyway, Dieter, I really want to know what is your take on this. There is some issues here for the monitoring of the moisture. We already discussed Raman with Hrebesh Diagnostic a few seconds ago. Room for cooperation. Ideas, please.
So I can, like what River D said is exactly right. So Raman spectroscopy can help to do a chemical profile of your skin, and if you do it, you can do the depth resolved with confocal microscopy and get good resolution, and both chemically as well as in depth. And if you choose a Raman spectrum that goes out far enough in wave number space, you can even see the water bands, see what the water is associated with other molecules. I know urea is one molecule that's of importance for the skin moisture discussion. So it gives you a lot of options. Raman spectroscopy, a lot of detail, and like I said, with confocal microscopy, you can even get the depth profile. So that, but I know that's already been explored in this direction. You just need a Raman spectrometer that gives you the signal here to interpret the spectrum.
Dieter, thank you so much for joining. Panayotis from Alplacer. I want you right now in the window here. I want everybody in the world to see the face of Panayotis. Panayotis from Alplacer. When I see this screen here, they talk to us about Raman. They talk to us about infrared, about leaf spectroscopy. I'm very interested about trying to have an end user case for the mid-infrared spectroscopy. I really want to go to the 3 to 12 micrometer wavelength region. Do you foresee, do you have, so I know you have something in mind for sure, any room for cooperation here in the longer wavelengths?
Sure. So there are many things that we could do in the longer wavelengths. There are a few projects that we already have where we're looking at skin and trying to look through the skin and assess it. We have a project that's ongoing where we're doing active illumination for hyperspectral imaging to detect the diabetic foot. We have a few projects that are in the 6 micron region where you have the amide bands, and that's where you can detect all these really interesting biomarkers. We have another project where we're using photothermal imaging in the mid-IR. So there are many options depending on what would be interesting to detect. So definitely there's a lot of room for discussion for spectroscopy and imaging combined.
Benjamin, Veronica, one of the reasons why normally we invite people to go to the mid-infrared wavelengths is because the absorption of water is never a limitation. Is there any application field, Benjamin or Veronica, that you can share with us now in which when you're doing the testing, when you're doing the sensing, water, different contents of water could actually be affect negatively the result of the measurement?
I'm not sure I rightly get the question. What do you mean by negatively impact the water?
In the mid-infrared, water absorption is not really a limitation for the spectroscopy. Is that an advantage for some of the applications?
I would say that go ahead.
They are next to each other in the room. It's so nice.
No, yeah, of course, there are two things that we want to be able to take correctly into account is the water absorption, because basically it blocks every signal. And there is the melanin content, because we want to be able to be as accurate, whatever the melanin content in what we detect. And so for those two reasons, going in the mid-infrared is a very good idea. And in general, it is. The difficulty for the type of project that we try to have is that we want to put this as in the point of sales. And generally, the cost of those technologies is still a challenge for this reason. So we like the idea, and now we have to think about a way to make it happen in a, let's say, cost-constrained environment.
We are setting up a mid-infrared alliance with all the different companies from QCLs to mid-infrared fibers to the companies who are making the detectors. I want to have a use case on this, and I want to give this little task to Panayotis. Panayotis, you need to interact with them and try to find a use case for mid-infrared spectroscopy.
Definitely.
But I want to.
It's all a matter of cost, Jose. It's all a matter of cost. Of volume. If they plan to put one such device on every store selling cosmetics, then for sure that the cost can drop dramatically, like 2 orders of magnitude.
I would also add that another point is that spectroscopy is something that, I mean, you measure just one point. When we are talking about skin diagnostic, we are interested in, of course, you can measure several points, but I mean, that's time consuming, whatever. And we're looking for really holistic skin diagnostics. So for us, it would be interesting to have a kind of mapping that would still be quite quick to realize. Or like Benjamin showed in his slides, to identify some key places on your face in order to know what exactly parts we should take and whether it would be representative of the entire skin or not.
We are doing exactly that in a project. We are scanning the entire foot, doing hyperspectral active illumination. So this is something that is actually being developed right now. So if you want, we can talk about it.
Fantastic.
Sure.
You have a question in the chat from one of the companies that in the video you saw how much I love, DAMAE Medical. Jonas, what's on your mind?
Okay, I'm in mute. Yeah, thank you. So yeah, my question was, so we talked a little about spectroscopy, but now my question was about imaging. So on to, the next, on your slide, the next, ID for analysis and diagnostic. And yeah, so what you showed is mainly, I think, surface imaging, like hyperspectral or, standardized illuminant imaging. And I think that's just for surface skin imaging. But I was wondering, do you also investigate in-depth skin imaging such as OCT or confocal microscopy? And, in my company, we work on in-depth skin imaging, and I was just wondering if that was of interest for you at some point for your analysis to go to the what's going on under the skin.
Sure. I think you're already aware that the colleagues of us from the clinical platform in L'Oréal, they already use the devices from DAMAE. I would say that for our team, there's not of much interested because we are supposed to work for the points of sale or for the home use. However, that is definitely of interest for our colleagues from advanced research and more clinical research. For us, it might be interesting as well to know the ground truth. I mean, that makes no sense to tell to the customer that you have that level of micrometers of wrinkles because she would never be able to really observe it. But for us, it's important to know what's really happening in your skin in order to make a kind of, let's say, high level diagnostic. So for these two aspects, yes.
We have on one hand the spectroscopy side. You're going to hear later from DAMAE because I'm very amazed with them on the OCT and confocal. But you also have, from the previous discussion, from the previous meeting, put a lot of emphasis on AI and on face ID recognition. And on that, from my point of view, when I look at the Facebook Messenger and they already put funny things on my face, I always believe that there is a lot already done, but could you give me like 1 or 2 items in your Santa Claus wish list? What is the next step? What is the next need for computer vision for face ID? Perhaps further sensing of every point, perhaps some chemical composition? Dream away, just dream.
I think that there are some great advances recently in 3D capturing. The fact that you get some 3D sensors in almost high-end consumer smartphones will probably lead to very interesting applications about what you can reconstruct about the 3D face. But as you said, most of this is well developed in the academics, and it's really about how to apply it to concrete use cases. And if I think of the example of skin diagnosis and the analysis of face features on a full face pictures, those are things that are quite mature in terms of technology. But then if you want to apply it to a practical use case and to use that to do some product recommendation, you just have a lot of work to put all the pieces together. So it's not as much as a wish list as a to-do list, let's say.
I would ask another important point that is not really very well addressed today. That's the inclusivity part. All these AI algorithms, they have been trained mostly and they work very well on Caucasian skin types. But if we want them to work from one phototype to the 6th one, that's a little bit challenging.
We do have quite a good network of companies on the AI side, but there is a member of EPIC who's helping companies for the 3D Face ID recognition and making the very interesting demonstrators from the end user side. That company is NTS Optel. Do I have somebody from NTS Optel in the room? Frank Ernst, I believe is in the room. Yes, Frank is here. I will shoot in the air. This is not prepared. I will shoot on the answer. Frank, you saw what they are talking. They are looking for partnership perhaps on dreaming away what can be done for Face ID recognition. You've done a fantastic job on pixels for that. What kind of room for cooperation could you foresee with a company like L'Oréal?
Yeah, actually, I think I see quite some areas because the things that Benjamin shows in this slide is the 3D profiling. We have a lot of experience with. We have some experience with spectroscopy, done already a lot in healthcare, make measurements devices that can actually measure some specific molecules in the skin, in the top layers of the skin. Raman spectroscopy, so that are, I think, all kind of technologies that we are very used to work with. I think there are many opportunities here.
Thank you so much, Fran, for being here. Thank you also, Veronica, and thank you very much, Benjamin, for being with us. Stay tuned because, of course, No surprise here. I'm gonna come back to you later. But now I want to talk to one of the companies who already working with L'Oreal has made a big impact in the EPIC network. We want to meet in the room Jonas Ogien from DAMAE to tell us a bit about how we can actually combine the needs on skin analysis with OCT and confocal microscopy. Jonas Ogien from DAMAE, one of the companies that we do love in this network. The floor and the attention goes to you.
Thank you very much. So let me just share my screen here. And here we go. Okay, can you see my screen?
Yes, but we need to see it in full screen mode, the way your technology deserves.
Coming up. Okay.
Fantastic.
Well, thank you very much. So my name is Jonas Ogien. I'm a research engineer at DAMAE Medical, and my screen just went off, right? Oh, you can still see it?
No, we can't, and I don't know what happened there, but...
Okay, let me try it again. It's surprising. So it should be this one.
Yeah, yes, it's working
now.
Is
it back? Okay,
perfect.
I hope it will stay now. Okay. So yeah, I'm a research engineer at DAMAE Medical. And my idea is just to introduce to you what we do at DAMAE and how what we do can help analyze the skin at a very high resolution level. And the idea is that DAMAE develop a new technology. Okay, I'm having, okay. A new technology called line field confocal optical coherence tomography, or LCOCT. And this technology is a combination of two technologies you might know, which are used for skin imaging, for in-depth skin imaging, which are reflectance confocal microscopy and optical coherence tomography. And the idea is that LCOCT combines the two to get all the advantages of those two techniques, including both vertical and horizontal imaging, cellular level imaging, and pretty decent penetration depths, resulting in these types of 3D blocks of skin in which you can really identify every cells. And I will go a little more into details in what you can see here. And so DAMAE developed this system, and I just want very briefly to walk you through technologically what makes this combination works. And it's actually we use so the different bricks are a broadband laser for high resolution as in OCT, high resolution microscope objectives like in confocal microscopy, line illumination and detection for confocal filtering, vertical scanning for vertical slice imaging, and a lateral scanning for en face or horizontal imaging. And so we kind of miniaturized all of this into a handheld probe. And you can see here the deep live system we are commercializing, and we just launched it last year. And we are now selling this type of handheld probe for high resolution skin imaging. So let me just once again show you what this probe can do. So it can do live vertical imaging at a rate of 8 frames per second, horizontal live imaging at the same rate of 8 frames per second, and you can also acquire 3D stacks in, let's say, 20 seconds to 1 minute. And on top of that, while you're imaging, you also have a dermoscopic image of the surface of your skin, which helps you to really target very precisely the region you want to image on the skin. And so now I'm going to show you a little what we can see in the images that are obtained using the DAMAE Medical Deep Live probe. And if you may be, you may be familiar with histology, and the idea is that we really get the same kind of images apart from the color aspect. And now the very, very interesting thing is that this is in vivo imaging. I mean, you really just put the probe on the person you want to image, on the person you want to know more about the skin, and you get this type of histological resolution images, which usually takes a very long time to acquire. So in these images, you can actually see different layers of the skin, including stratum corneum, living epidermis. You can clearly see the junction between epidermis and dermis, and onto the superficial dermis and reticular dermis. And within the epidermis, you can really see individual keratinocyte nuclei. And at the junction, you can see different papillas. And then within the dermis, you can see blood vessels and fibers. And from those images, so those images that really tell you a lot about your skin. But now we want to go past that, and we want to have really quantification of the skin using LCOCT images. So we developed a lot of algorithm, mostly based on artificial intelligence algorithm, to automatically give you metrics of the skin. And so I would quickly go through the metrics we can have using LCOCT. So the first metric you can have is actually measuring the skin layers. And so you can measure the thickness of the different skin layers, and you can actually get maps of the junction of the different layers. And from those maps, you get a lot of information. For example, the undulation of the epidermal junction, or the roughness of the skin surface, and so on. And yeah, I really emphasize the fact that this is automated segmentation based on artificial intelligence. Here is a little example of the interest of skin layer thickness measurements. So this was applying a skincare product, and we could see the fact that there was an increase in skin layer thickness, especially stratum corneum and living epidermis. Then onto the cellular level, we got other algorithms which give you segmentation of the nuclei, the keratinocytes nuclei within the epidermis. And from this segmentation, we get a lot of very interesting information, including distribution of nuclei, different size of the nuclei, density, number of cellular layers, and so on and so on. We can do the same thing for the melanin. So melanin, it's a characteristic for pigmented skin. And for example, we can measure the melanin density of a particular skin and look at how it evolves over time. And eventually, I will go to the tissular level. And so this is mainly within the dermis. And we can also give metrics about the collagen. Here is just two images of LCOCT for young versus older collagen. And from those kind of images, we can give anisotropy score typically to try to quantify the difference in collagen between different types of skin. And eventually, the last metric we can do is about blood vessels. So we can segment blood vessels, and we get information about blood vessel size and organization, which can be very interesting. And again, this is in 3 dimension, in depth, in vivo. So to conclude, the idea that DAMAE Medical develops a very high resolution imaging system for skin analysis, pairing penetration, depth, and cellular resolution, and 3D imaging. And we developed a whole bunch of AI-based algorithm that can be actually used to give a full range of possibilities to optimize preclinical research and develop or characterizing active ingredients or efficacy of cosmetic formulations at 3 different levels, including skin layers, cellular layer, cellular level and tissular level. And eventually we also, we work a lot with our customer to develop collaborative test protocols, and we really design custom studies with different levels of tailored and interactive reports. And with that, I'm thanking you for your attention. And I'm really looking forward to discuss with everybody that's here about what we do and what we can do, and ask the epic questions.
Yeah, that's exactly how we're going to start. But first, I would like to tell you thank you for this fantastic presentation and this fantastic technology that you're presenting. I mean, I really got a little bit of flashbacks of my histology lessons. So working in the lab with the histopathology, it's so clear what your LCOCT is showing really down to individual cells. So let's indeed start with the epic question though. So you showed us quite a bit what you can do with your technology, but we have also 700 members here ready to work together with you. So what they can do for you, what is that you're wishing for? What is that you're dreaming for?
Yeah, so right now, I think so I'm an R&D engineer, and what we're working on is a lot on miniaturization, because I mean the handheld probe is already pretty small. I mean, there've been a lot of work to have something that you can actually use on any part of the body, and which is not so heavy, and you can hold it with your hand. But still, it's often a kind of a problem that it's still a bit heavy, about a little more than 1 kilogram. So we're working on new optical setup, basically how we can get the same images and the same level of details, but maybe with new optical, optical setup and optical technique. And and how do you get something lighter in the end and smaller? Because especially for cosmetic use, sometimes they just they run this, they acquire this type of images for the whole day or even a few days, and
Very
at some
true.
point it gets a bit hard to use those, but still it's possible. But we want really to increase that, and obviously we are looking into all related to cost reduction, because this is still pretty expensive devices, such as, I mean, it's similar to confocal microscopy if you use to that. We are more in this kind of range.
Jonas,
yeah.
Let's investigate. Let's see what is out there. I already see some propositions of collaboration from Dirk from Topic. Dirk, do you want to also tell us a little bit on how you think you can help Jonas?
Sure. Thank you. Thank you very much for your presentation, Jonas. The coincidence is that after this morning, actually, I had a discussion with my colleague who's also named Dirk at Topic, and we discussed your device because I really liked it, and I showed it to him, and he's a real technical guy, and he told me, well, if you want to collaborate with that company, I could imagine that we could work on it, getting the device smaller. So he actually already told me that would be interesting to look at, to discuss it with you guys, because I heard you guys, I didn't know you guys were looking for that. That could be really interesting to have a more technical discussion about, to see how we can work on that, because it's a beautiful device and with a beautiful technology, but it could be more convenient for the caretaker and the care receiver if it would be a little bit more smaller.
Yeah, thank you very much. Thank you very much. We'll be in touch. And just for the sake of curiosity, do you know what he had in mind when he just said, I could make it smaller?
He has a magic wand. And no, I can't tell you in detail because I'll probably pronounce it wrong, but he had some ideas, and I would love it to set up a meeting with you guys and him to have a little brainstorm session about it to see, or it could meet your demands and your requirements.
Okay, well,
Fantastic.
Thank you.
So we're establishing some collaborations, but we have so many questions in the chat right now. So let's also try to see if we can have enough time to answer everything. So the first question was from Dieter from Wasatch Photonics. Dieter, what is that you would like to ask Jonas?
Just a quick question. So I'm not the OCT expert, but Wasatch also basically comes from the grading side, and lots of those are used for OCT. And I was just wondering, is your OCT spectrally resolved, or is it a time-based? So like I said, I'm not the expert, but if it's spectrally resolved, then I can maybe see some collaboration here for the grading side.
So it's not spectrally resolved, it's a time domain system.
Okay.
And very, very quickly, I can explain why we choose that. So the idea is that we do dynamic refocusing, and that's what gives us our very high resolution. And the problem with a spectral domain is that it acquires the A scans in one single shot, and you cannot actually do the refocusing over the acquisition that we are doing.
Okay.
Yeah, that's the reason.
Okay. Just
Great, thank you. Well, we are aiming to keep coming to L'Oreal with questions. This time we have a question from L'Oreal. Veronica, what is that you would like to know?
Yeah, I was just curious about, because you mentioned that you also try to do OCT and to evaluate the efficiency of the products. And we are always thought that our products, they work on the skin surface. And I was curious about whether you saw some changes or whatever that's happening just maybe under the skin surface, not only in the stratum corneum.
Yep. So yeah, that's a very interesting question. And so that I'm aware of, it's actually the one I show on one slide pretty quickly. I think for a skincare product, we already observed a thickness, an increase in thickness of the whole epidermis. So it's just not at the level of the stratum corneum, but we could really see differences. Apart from this example, I can share. We've also observed a difference in melanin distribution, so really in depth. So I'm talking at the level of the junction between the epidermis and dermis, and we could observe a decrease this time in melanin distribution after the applying of a phototherapy. Something to remove basically your spot. Medically, we had pigmented skin and we wanted to remove that. So this is, I mean, you could tell me this is something you can definitely see on the skin level, right? If it's just going off or is it staying? But apart from that, the interest of LCOCT was also to really quantify what was happening in the melanin. So really at the cellular level, like what is going on when my spot is actually going away. And this is an example on a particular skincare product. I don't know if there's anything more I can actually share, but there will probably be some communication in congresses real soon about other examples that the two I'm really quickly mentioning here.
Okay, great. Thank you. I am asking because we are really very, very focused on more skin surface diagnostics because we are convinced that the main effect of our products, we can see them only on skin surface. But if you really can see something deeper when you apply or not the product, that's great to know.
I think, well, my point of view about that is just that it can give you just more information, right? If you limit yourself, you've got the main information you need from the surface. But I'm thinking you can really get a lot of interesting information that can maybe help you, maybe just not to assess what's going on the surface, but maybe assess other things, or for example, to certify a product is actually working as expected, and maybe you can actually use in-depth metrics to prove that. That's just an example, out of my mind right now. But yeah, I'm really thinking you can get a lot of more information by going in depth.
Okay, let's move on. We have many more questions for you, Jonas, to answer. So we have a question popping up from our other end user here in the room, from Colgate, from Hrebesh. So what would you like to ask?
Yeah, I'm just wondering about the field of view of the system, and also whether it is a contact or non-contact mode of operation.
Yeah, very interesting question also. So this is a contact system. You really put the probe on the skin. So the way to see it is really like, I see it like ultrasound. Like you got an ultrasound probe and you put the ultrasound gel on the skin, and then you put the probe. It's the same basically with our system. It's really like an ultrasound probe. And about the field of view, so it's a microscopy system, right? So the field of view we have is 1.2 millimeter per 500 microns per 500 microns. That would be our cube.
Can you resolve topographic information?
Yeah, so you can get topographic information. The only thing is that if you consider skin surface, you got to remember that you put the probe onto the skin. So maybe this will affect the way you got to consider your topographic information. But what I think is really interesting with LCOCT is that you get topographic information from the dermis-epidermis junction. And I think this is something pretty unique that the device can give you, because we are talking about in-depth, in-depth structures, and something that's not so easy to get. And confocal microscopy cannot actually do that. And OCT can, but the resolution wouldn't be high enough to really get metrics out of that. So I think this is, but topography, I believe this is a very, very unique and interesting features of LCOCT.
And what depth it can go?
Sorry, what?
The in probing depth, is
Yeah.
it?
So as I said, it's maximum 500 microns.
500. Okay, thanks.
Okay, great discussion going on. And I see that Panagiotis from ELPS lasers, from mid-IR lasers, is already taking in action what Jose was asking him to do and bringing mid-IR deeper into cosmetics and beauty industry. Panagiotis, what's on your mind?
It's actually a follow-up to the exact previous question related to the penetration. So I imagine you're using some off-the-shelf light sources, right? Are you using 1550 light sources?
Not at all. So what we are using, and we actually already we published something about specifically about the wavelengths of LCOCT. What we're using, it's almost visible light. It's centered around 800 nanometers. And there's a lot, there's been a lot of discussion at DAMAE about what wavelengths should we use. And there's actually been a PhD student that did a whole part of his PhD on like trying to optimize the wavelengths for LCOCT. And our conclusion, what the problem is that you always have a trade-off between penetration, resolution, but also speed. And why speed is that if you want to go deeper, then you will not, I mean, we'll go slower, basically, because it's dynamic refocusing, and it's really, there's a physical movement of our objective. And our conclusion was actually that the main advantage of LCOCT and the main differentiator of LCOCT compared to other OCT techniques was cellular resolution. And there should be absolutely no trade-off on the resolution if we want to have something relevant. So we identified that if we use the 800 nanometer wavelengths, then we get this cellular resolution. Why not, reducing too much the penetration? And actually, if we want to have a live imaging anyway, we cannot do much more than 500 microns. So this really seemed like the good trade-off concerning those different things. But interestingly, we also did, we constructed a dual wavelength system, which had a 800 nanometer wavelength and a 1.3 micron wavelength. And using that, we could actually combine the images to have both a very high cellular resolution in the epidermis, but also a longer penetration depth in the dermis. But the conclusion to this work was that actually it was way too expensive and complicated to worth it, basically, because the penetration gain you had at 1.3 micron was not, significant enough.
Jonas, be prepared to many introductions after this presentation. You're going to be amazed. I want to introduce you to some of my friends. I'm going to go to Finland, one of our key members in silica glass processing from optics to fibers. Let me know, Kimmo, what you have in mind.
Thank you, Jose, and thank you, Jonas, for the really nice presentation. So I'm a simple guy, and that's why they put me into sales. But anyway, I'm not an expert in OCT, but in one of your slides, I just noticed that you have had a fiber, a laser, and you must have a laser connector. So my question is there anything special with the fiber or fiber connector? Are those off-the-shelf things that you buy, hopefully not from China? Thank you.
Yeah, it's really off the shelf. It's so off the shelf that I think I can say it's Thor Labs. So yeah, it's really, there's really not anything special in the fiber we use. Basically, we have this big laser, we have this big super continuum laser, and we just want to bring the light from this laser to our system. So basically, it's really just a monomode fiber, which we put on, we connect it to a collimator, and then it goes in the system, and then the magic happens.
Thor Labs is a great Epic member, and I know they are watching, so hello, thank you so much for providing DAMAE with great technology. One more question is coming also all the way from Finland, from VTT. This is the R&D center that can help you with miniaturization, really the one. Alexei from VTT in Finland, what do you have in mind? You are muted. To celebrate such event, I'll send you a Mac.
Hello, everyone. Yes, greetings from Finland, 200 kilometers from the Arctic Circle. but here we have already spring. Snow has melted plus 15. Jonas, thank you for nice presentation. I have a few questions. First, I mean you mean that you measure not the real thickness, but optical thickness. Is it correct?
Yes, correct.
That's correct. Next question.
Next question. You told about speed. Have you thought about using a Fourier transform instead of time domain option?
Yeah. So this will be. I will give the same answer I gave before to Wasatch Photonics. So why we don't use the Fourier transform and the Fourier domain OCT is that to get the very high cellular resolution, we need to dynamically refocus our microscope objective over the acquisition. And with Fourier domain OCT, you acquire the whole depth in a single shot. So if you acquire the whole depth in a single shot, you cannot actually move your objective during the acquisition because it just instantaneously acquire. So we use time domain OCT.
And I'm going to go to the next question. Jonas, this is like Eurovision. We go from Finland to France. The company is Irision, one of our key companies in picosecond lasers for medical. Let me know, William, how you can help DAMAE. William from Irision. He is muted, but he's here. Yes,
that's
William.
Okay. Thank you, Jose. Yeah, I just my question is about the ink concentration into the skin, and I would like to know if you already tried to do this kind of measurements because it's mainly interesting for us and for all of people with tattoos and that would like to remove the tattoos. It's a key information to know the ink concentration and to help the users of lasers to change the beam parameter of the lasers on the skin. Is it something that you try to do?
I didn't get it. Like the what concentration of what?
If your ink concentration into in the skin, is it something that you
ink concentration
for tattoo removal?
You're talking about tattoo removal, okay?
Yes.
To my knowledge, we've never we've never tried one of our device for this use. So I don't think this has been done before, but it would definitely be something very interesting to look into.
It is a very, very interesting market. You're going to have a fantastic discussion. And the final question of this fantastic Q&A comes all the way from Israel. Everybody's vaccinated there. I'm so jealous. I want to go to Karen from Holo. Tell us about diffractive optical elements.
Hi, Jose. Thank you. So all the way from Finland's melting snow to heat waves in Israel, we manufacture diffractive optical elements which are used for optical beam shaping. And my question to you is your beam shape optimized for your process? Is there something that you would like to change, or you think that by modifying the shape of the beam on the skin would provide better results?
Yeah, so I didn't really go in this level of details in my presentation, but I think I said it very quickly, but our beam is a line field, like it's really a line focused on the skin. And my point of view, well, to do that, our approach is very simple. It's basically just to use a cylindrical lens and, focus a line on the skin. And we try to use the appropriate focal length of this cylindrical lens so we can get a length of the line that's appropriate for our field of view, basically. My point of view regarding changing that would be, I think it would be interesting mostly if this could lead to an improvement in compactness. Like if you can get a smaller system, then this would definitely be something very interesting. Unfortunately, I'm not very familiar with this type of optical elements, but I would be very interested to know more about them if they are interesting regarding
Oh my God, DOEs are a passion for Epic. We organize this kind of events about DOEs every 2 weeks. And our key company there is Holo. So you need to talk to Karen. And so it's also super nice. Thank you, Karen, for joining. Jonas, I'm going to ask you a question from the YouTube channel. Feel free not to answer if you don't want. But the company is KLST from Belgium. This is an Epic member developing customized CMOS sensors and SPADs. And they asked me, what is the difference between the DAMAE medical product and the skin tel from ACFA?
Yeah, this is, wow. Where did you get the slide?
I cannot, well, it's in the public domain.
Okay. This is a very, very interesting question and very specific. And I'm glad somebody asked that. And I can really explain, well, I've never really fully understood how the Skintel system works because they never published anything. I mean, they published patents, which I try to understand. And they published clinical work mainly. And by the way, we're working a lot with the University Hôpital Libre de Bruxelles, with whom they worked before. So we know a little about this technology. And the main difference is that Skintel is full field OCT to my understanding. And so basically they just illuminate the whole field of view to be image, a 2D field of view. And they do an image based on that with really, really nice technological way to do it. And we do line field illumination, meaning we only illuminate one line, and we scan this line to obtain images. And the difference resulting from that is that the resolution for LCOCT is higher and the penetration is also higher. And another main difference is that the system is much more lighter. I mean, the LCOCT system. The Skintel system was very, very heavy. And actually that's
very,
why
very heavy and really big. And let's not compare competing instruments, but thank you so much, Jonas, for addressing the question. I thought you were going to say no, but thank you for addressing it. I think it's truly great that there's always room for cooperation. One of the longest Q&A sessions in the history of online technology meetings, but now everybody has been waiting for this. We need to go to Colgate. Hrebesh, Molly, Subhash, end user Colgate. I met your colleagues in CES in Las Vegas. I was amazed at what they can do. Tell us about what we can do for my favorite toothpaste provider, my favorite dental company. I'm so happy to have Colgate in the room. The floor and the attention of everyone more than ever goes to you.
Thank you, Jose. Thanks for this opportunity. I'm Hrebesh. I'm going to share my screen.
Yes, please, with a big Colgate logo. Make this day epic.
Can you see my screen?
Crystal clear, like your smile.
Okay, wonderful. Yeah. So I'm joining from our Global Technology and Design Center, which is located in New Jersey. So I will give a brief overview about various photonics technology we work with. We extensively use photonics technology in various aspects of our research. And so we have one of the key area is our advanced imaging technologies. We use a wide range of photonic imaging technologies from various resolution ranges from a sub-nanometer millimeter range. It's include AFM10, SM, light microscope, multi-photon microscope, OCT, and the whole phase 3D imaging systems. Actually, we support, we have around more than 60 brands, both in oral and personal care. These are some of the key brands we support using this technologies, specifically in the product development phase. For example, knowledge acquisition, studying the mode of action of different ingredients in the skin, both in ex vivo and in vivo type of scenarios, and for clinical trials and studies. And another key area is developing a next generation instrumental cosmetic devices and digital health devices. So we are exploring various platforms like therapeutic devices, and for these are for consumer applications, low cost, and you can use it to your home, because most of these photonics based therapeutic devices, these are very well established technologies. As the L'Oreal just mentioned about how they're trying to, so we are somewhat in similar areas. So we are trying to develop low-cost therapeutic devices and diagnostic devices for consumer-level applications. So we are exploring various type of photonics technologies like time-of-flight cameras, MEMS, microspectrometers, lidars. So I can give some of the examples in the advanced imaging technology, what we do. So one of the technology we are currently exploring is optical coherence tomography. Some of these devices we built in our lab because some of these devices are not commercially available for our specific application, and some of the devices are off-the-shelf devices, and we need to re-engineer those type of devices for our specific applications. This is a tomographic system. It's a multimodal system. It can give you both structural and functional information of tissue. So we use this system for studying both oral tissue, soft and hard tissue, as well as skin, facial imaging. And so it can give you very high resolution structural and functional information. For example, this is an example of a normal gingiva, and this is a gingiva with gingivitis information. So you can see angiogenesis here, and this is a normal. So we can do a lot of things. So we have developed a lot of various types of algorithms for quantitatively analyzing this system. And another technology, these are where we use this type of system for proof of concept studies, not widely for clinical studies, clinical trials. So we have another platform. This is something like an off-the-shelf device. This is a 3D intraoral scanner. It's typically used in orthodontic application, but we customize this for extracting colorimetric analysis and for topographic analysis. So you can get multiple information like tooth color, gum morphology changes. Even you can get fluorescence imaging from this. You can quantify plaque or biofilm using this scanner. So we are using this platform for our clinical studies, and these are some of the high-end devices we are currently developing. And another technology currently we are building is a snapshot multispectral spatial frequency domain imaging. So as you guys talking about the quantification of hydration, so this is one of the very nice technology you can use for a quantification of hydration, because using the spatial frequency domain imaging, you can extract absolute scattering and absorption coefficient of skin at surface and subsurface level, and you can use very sophisticated Monte Carlo modeling, tissue model for extracting various type of skin parameters. It's like we use this for both oral and facial imaging applications. It's still in the developmental phase. And another technology is 3D optical imaging. So we use time-of-flight cameras and structured illumination cameras for extracting, because we work with some of the high-end cosmetic brands like PCS Skin, LTIME-D. So this can provide topographic information, colorimetric, reflectance, and fluorescence type of information. And so these are some of the key technologies we build, and other systems we buy and engineered for our applications. And so these are some of the our consumer level products. So we have a brand called Hum toothbrush. This is one of the connected toothbrush platform. So this is based on a 9-axis MEMS technology. So this toothbrush can track your brushing habits. It can guide you how to brush you well, and it can time you, and it can provide a lot of information about your brushing habits. And we do have another brand. Actually, this is a kids brand. This is a toothbrush with augmented reality. It's a gaming toothbrush. So we use machine vision technology for tracking and use augmented reality platform for giving the kids a new experience to do brushing in a very fun manner. And this is a very successful product. So this is another platform. We use camera technology, and this is instrumental cosmetic platform. So this is our advanced whitening platform. This is based on pretty new technology. It is a dot printed blue LED. So it is used for home-based whitening. So typically there are whitening devices that is used in office. Those are very expensive, and it's high cost platforms. So now you can buy this and you can do whitening at your home using photochemistry. So we explore this type of platform for consumer applications. And next is our, this is not yet launched. This is our Plaqueless Pro toothbrush. This is the first toothbrush with the integrated optical sensor. This can map your plaque buildup. And it is a toothbrush with a hybrid platform. It has both integrated optical sensor and inertial measurement sensor. So it can track your brushing habit as well as your oral hygiene information, and it can map you and are very sophisticated. Actually, all these technologies are backed up by AI technology. So we use machine learning models for training and building these platforms. And so this can, currently this is used for plaque detection, but the sensor is capable of extracting a lot more information from the oral cavity. So we are planning to launch this product pretty soon in the market. So these are some of the cool technologies we are working on. And so we extensively use photonics technology in our research, especially in the cosmetic research, for developing various type of imaging modalities and instrumental cosmetic space, specifically for light therapy, laser ray surfacing. These are some of the areas we are currently exploring. And another thing is the digital health, developing next generation consumer sensing devices. Yeah, that's all from my side. Thank you all. So if you have any question, you can ask to me.
Fantastic. There are definitely a lot of questions to you. I will just take the privilege to be first one to ask them, because there are so many showcases you're showing to us so many different applications, and I know that some of them you also have next to you, so we can also see them in more real than a picture.
Yeah.
But what I would like to ask you, so since there are so many applications and so many products, is there something you would like you're dreaming of that it's not off-shelf available? We have like 700 members who are developing the top-notch, the cutting-edge photonics technologies. So is there that maybe the full list, or maybe that one little thing that's like, oh, that would be great to have?
Not only one thing, I need a lot of stuff. So one of the stuff I'm currently looking is a tiny time of flight camera, not only time of a 3D sensor, imaging sensor, ultra low cost for a specific application. That is one of the stuff, and I have a lot more light sources, detectors, miniature, light panels.
Okay. Fantastic. So while Jose is checking everybody in the room and he will start bringing people to you, I would like to go to Veronica from L'Oreal with her question.
Here again, I know nothing about dental care, but what you presented about the sensor that you have in the toothbrush made me think about the product of Procter & Gamble, the OptiThink that they use on the face. When you use a device that you move on your face, it detects something wrong, and then it delivers a product. So my question was about, have you already think about that thing, but for the dental care?
Of course. Of course.
I mean, I even don't know whether it makes sense to deliver something specific to your teeth, but I mean, maybe when the
Actually,
sensor.
we have some products. We have a toothbrush with integrated a toothbrush with integrated product. It can deliver. We have a whitening. It's called Optic White. So that you can, it has a filler you can put inside your, I don't have that model here. So it just like you can press it, it apply the whitening products through the toothbrush. Actually, it's a delivery system integrated inside the toothbrush.
But I mean, it delivers the thing actually on the point that is problematic or everywhere around your
Currently, it is better. You can do that. You can do that. So once you have optical sensor, you know, it's everything is doable. Yeah.
Great to know. Thank you.
Hrebesh, you were waving already a couple of times the toothbrush next to you. Can you actually share it with us?
Yeah,
Can you
actually,
show
this
us?
is this is the Plaqueless Pro. So this is the one with the optical sensor. You can see it's a functional one. So it is currently it is sensing. It's a fluorescence. Actually, it's a blue LED. It emits the fluorescent excitation, and we have a
how many blue LEDs? I check in a press release 700.
Yeah, actually, it is a 2 LEDs. You can see 2 LEDs, and middle is the sensor, optical sensor. So I can take this off. Can you see?
Okay. it does look truly fantastic, and I really tried to make in the opening video a little bit of noise about this. Let's talk about cooperation opportunities here. So in the first, you talk about OCT, you talk about multispectral, and you talk about fluorescence. I want to start with the multispectral side. On the multispectral imaging, at the end of the day, what we are doing is doing chemical composition inside the mouth, which is the location of the body in which you have most water. And I guess that's always a problem for doing multispectral imaging. How do you address that? And is there any ideas of going to different wavelengths, perhaps longer wavelengths?
Yeah, actually, we use currently we explore this platform for visible range. That is from 650 to 980 nanometer. We have a system. It's a camera. It's a camera with multiple. This is a snapshot sensor. It's a pretty new technology. One camera with 16 channels. So one shot you get all the spectral channels. And we use this structured illumination with different frequencies. So you can get a very absolute scattering and absorption coefficient. And we use a very sophisticated Monte Carlo model. We have a model for the visible range and shortwave infrared range that is from 1 micron to 1.8 micron. So there you have water bands. So if you have a sensor, if it can go up to 2.2 or 2.4 micron range, then you have multiple. You have a 1450 nanometer, and you have a bound and unbound water range that is 800. You have a couple of bumps. So we can use that for extracting. So currently we have a sensor that operates up to 1.8 nanometer. But yeah, we are currently exploring.
With the 1.8 micrometers, you need to go.
It is.
I would recommend to go into the 3.5 to the 7 because of the. But we're gonna find you the partners for that. I'm gonna find you the partners for that.
We are really interested. If you have, actually, we are not interested in point sensing. We are interested in imaging the whole face of skin. So we want to map.
Hrebesh, I normally ask our members to dream away, and the resulting fantastic questions. William from Irisium, what's your question? I'm very interested about the answer.
Hi. Yes, thanks. I was wondering if we know that lasers can be useful for dental cleaning, and do you have already some ongoing test, or are you looking for partners for that?
Actually, currently we don't have a sensor that can operate up to 2.4 micron range. So we are looking for a sensor that can go up to 1.5 or 2.4 micron range. It can cover the entire shortwave infrared range. So most of the sensors currently available are up to 1.8 microns. So in terms of a light source, we use supercontinuum light source from NKT, so that can we can do spectral imaging.
We're going to find you the right partners also for the super continuum, which is a topic that we are addressing very strongly at EPIC, and many of our members want to help you on that. I was amazed already for a year and a half. I'm very amazed about the magic toothbrush, the Colgate optic whitening. But this is today, this is already 1 year old product. What is next? And I don't expect you to reveal inside secrets, but make us dream something. What's the future looking like?
Yeah, actually, we wanted to have this type of technology. Currently, this low-cost dot-printed LEDs, we have around more than 700 dot-printed LEDs on that. Actually, that's in my hand here. You can see.
Yes.
So this is a single color. We want multiple colors. So we can use that for various applications, for light therapy, and for photochemistry applications.
You know, I keep asking my members to dream away all the way from Torino, Convergent Photonics, Andrea Agliati, although I think he's based in America, but the company is Italian. Andrea, what do you have in mind?
I was thinking, using plastic fiber on your toothbrush just to guiding the whatever is the laser radiation or the LED light directly on the tooth surface.
That is, you're talking about integrating that with the toothbrush with bristles.
Right. So having the toothbrush that has all the plastic fibers that is ending directly.
Yeah, that people proposed, but we are going something in different ways. So we are interested in this. Actually, this is going to be the next generation mouthpiece-based toothbrush, and this type of devices. This can give you benefit for the entire oral cavity at one shot. If you have something like brush, it's time-consuming. You are not going to cover all the parts. If you have something like this, it's pretty. It's a very straightforward application.
Hrebesh, you are a hero for us. You brought Colgate here, looking for partners, looking for cooperation. Be prepared for many meetings following up this call, and be prepared for us keep knocking on your door. We want you more often at these events. Thank you. It is a dream to have Colgate today. And this is like Eurovision. We had a question from Italy. We stay in Italy, but we go to Milano to talk to one of the success stories of Europe in the business of medical lasers, because they are very active in aesthetic and surgery, but they want to see about advanced beauty. Let's welcome to the floor Quanta System. What an afternoon. Quanta System to talk to us about how the EPIC members can help them being even greater than they already are. The floor and the attention of everyone goes to one of my favorite medical laser companies in Italy, and goes to Luca Cerri. The floor and the attention of everyone goes to you.
Hello, everybody.
Hello, Luca. You look fantastic.
Oh, thank you.
Tell us how we can help you. Tell us how we can help Quanta. You can share your screen?
Yeah. So first of all, thank you for the introduction. Now I'm sharing the screen. Probably you have it.
Yes.
And good. And I would like to introduce just what Quanta is doing, what it's doing in the aesthetic and the medical field, in the dermatological field, because we are also making products for urology, especially for urology. in the surgical field. But in the dermatology and aesthetics, we are from about 25 years in this field, and we develop some really unique technologies for this field. So I would like to start from a general introduction of the company, founded in 1985, and starting at the beginning as a company working in the scientific field, so making lasers for labs, and then started the business of the medical. And right now we are pretty big, because it's a pretty big facility with thousands of lasers produced every year, lasers for the professional market, not for the consumer market. And we have obviously certifications all over the world. It's not easy, and would be much more complicated. Probably some other people are working in the medical devices, they know, with the introduction of the new MDR's regulation for the CE mark. And this would be really not easy in the next month, especially because we don't know the rules. I don't know if you are advised about that, but we have to play without the rules at the moment. We just know that we will have the new regulation. We are more than 230 people just in the headquarters, and with many other people working in other companies around our facility. So we have a pretty wide portfolio, and one of our goals must be to make something unique. So not just lasers or medical laser units similar to the others in the market. They have to be really unique, but with a sense, obviously, and the sense is clinical, so it must offer clinical advantages mostly. And because the lasers basically are interacting with the tissue in these main ways, from photochemical to electromechanical, so to really removing the electrons from the matter, basically, we can play with these different kind of interactions, passing through the most diffuse, which is the thermal interaction, playing with the irradiance of the laser. So we need different sources and different devices that can work at different level of specs, not only different wavelengths, but also different kind of basically irradiance. So time, peak power, very important it's very important sometimes for this kind of applications, for some of these applications. And not only, also sometimes combining different wavelengths. We know that wavelengths are absorbed by different chromophores, and sometimes even for the same application, like in this case is an example of a hair removal, we prefer to use more than one wavelength. This to create such as a virtual new wavelength. Don't be offended by these specs, but playing with two wavelengths and changing the amount of one respect to the other one, we can really do different kind of you can say different kind of also in deep level of heating, as for example is visible in these computational calculation. So in this case, we can see on the right that using the mixing of 1064, which is a wavelength that can penetrate deeper than 755, and is also less absorbed by melanin, we can have less heat in the upper epidermis, and anyway, a better heat of the deep hair follicle. This kind of principle of work is also adopted to the skin rejuvenation, like for example, mixing ablative and non-ablative wavelength. Ablative and non-ablative wavelength basically have different water absorption levels. So more water absorption can ablate more easily the skin compared to less absorbed by water wavelengths, and combining them, histologically we can have this difference. On the left, just the CO2, for example, which is one of the ablative laser. On the right, a non-ablative laser, 1.5 micron, with in the center some CO2. This can create a much wider coagulation and a more superficial, for example, ablation. This is to also to tune what for us is very important, so the healing time, so the downtime of the patients. that can request, is always obviously the tendency to go on a non-invasive procedures, This to get results that are that affect improvement that can affect also the deep layer of the skins without ablating too much, so reducing the downtime. There is also a new way we are adopting in the latest years, which is really the formation of plasma bubbles into the epidermis or dermis using very high peak power devices. In this case, it's a picosecond laser working at 1064 nanometers that with a fractional, so-called fractional applications using very thin spots into the treatment areas, is able to concentrate energy in very, very small points. This is creating this expansion, gas expansion into the skin. And is absolutely related with no thermal effect in this case, even if it's offering great results, especially in treating scarring tissues, fibrotic tissues. So this is really a brief introduction, but just to put already some questions to all the people in this meeting, is that for us would be very important, obviously, to try to replace as much as possible this kind of tests, so histologies. And we were talking about OCT or confocal microscopy, and you can see that we need to reach important depth of penetration into the skin to, for example, replace this kind of test. These are always, obviously, tests that can be done ex vivo sometimes in vivo, and sometimes requested by the single organization of approval, like also the American FDA, also on animals sometimes, and we want to avoid this as much as possible. It would be nice to try to find a new standard to demonstrate the performance of a laser. It's true that to demonstrate improvements, this can be also, we've done also already some research using OCT and confocal microscopy to prove that there is an improvement of the superficial in the superficial dermis, and there are some doctors worked with this device that already published some articles on this, and this is good. But we need also to go as deep as possible with a good resolution to replace these performance tests. Thank you.
Lucas, thank you so very much for this great presentation and amazing laser technology Quanta system is developing. Thank you. There will be a lot of questions and follow-up to you. And since you said already yourself, there is quite a room for cooperation with the different imaging techniques. That's a question which I was having in my mind. But next to the cooperations already on this high level, let's try to get the answer to the famous EPIC question. So you also explained a bit what you can do for the others with the technology. What else can they do for you if we look into the technology, into the hardware, to the heart of your technology? Is there something you're dreaming of?
Yeah, I told you already about some of the diagnostics. We have to improve for sure the potentials in the diagnostics. Can you hear me? I can see everything freeze.
Yes, maybe you would need to turn off and turn on your camera, but we still can hear you well. Or maybe not anymore. That's what happens when you do online meetings.
Yeah, this is the magic of the live meetings. And when we had the person from Luca, and we worked so hard on having Quanta system here. And now we can see that he's unmuted, but we see him very, very dark, which it is not a problem because the show must go on. Luca, are you with us? You know, we lost Luca. Why don't we go now to Luca? Are you with us?
Yes, I'm online again. Sorry.
The question from Elena was very clear. Dream away. Tell us about one particular item in your Santa Claus Christmas list.
Yeah. Already about the diagnostics, I told about the OCT, but is not the only one. So for sure, we have to integrate something to make treatments more easy for the operators. So we are in the professional business, okay, professional laser therapist, but we need something to diagnose for the better diagnostics, like camera to detect the temperature on the surface, or systems to detect temperature on the surface, or to detect the amount of melanin on the surface, but can be enough small to be put on an MPs, for example. So this is one of the things we need, I think this is one of the most important development we have in mind in the next future.
And you didn't specify the wavelength range, if it's short wave or mid wave infrared. So be prepared to many people asking you questions on that offline. We have 4 people who want to ask you questions live. The first one is coming all the way from Finland. VTT, Alexei, what do you have in mind?
Hello. I have a question. If the laser systems are the laser systems suitable for rejuvenation of skin? And if so, what is the illumination pattern? Is it like just a single beam, or it's a kind of patterned beam? Thank you.
So you mean the kind of beam, the quality of the beam?
Number of beams in a
single mode or multi-mode, if it must be something like that,
no.
or if you mean, okay, for rejuvenation, so we are using both the systems. So the fractionated technique is a multi-beam application with always some spacing between the dots, between the affected treated skin. It's called fractionated because we are just treating a fraction of the skin and not the 100% of skin. This is to reduce the aggressivity of the treatment and to reduce the healing time. So this is the most diffuse one. It's more than 15 years that this technique is in use. Started with a 1.5 micron laser, and now is applied to almost every wavelength.
When we had these meetings, Luca, we always try to match the companies who we think can do business together and the ones that it will be difficult. I really would be very happy if Jonas from DAMAE and Luca for Quanta could find a way of cooperating. Jonas has a question. Jonas, what's on your mind?
Yeah, thank you. Yeah, I was wondering, when you're targeting the skin with your laser, do you have any imaging systems that helps you to target where you're precisely, or is it like a wide guess on, I will target roughly this zone, or do you need, what precision you need, and do you have an imaging system embedded to help you get this precision?
Yeah, in the rejuvenation treatments, as I show you, there's no needs to much precision. We have to treat almost all the skin with a certain approximation. So we are not to be really precise. In the case of pigmentations or tattoo removal, it could be, even if a wavelength is selective on pigments. So even if we are illuminating also external portion of the skin, typically there's no interaction there or minimal interaction, and it's not so important also that kind of precision. What is important is to quantify, for example, the dose of the laser. So the quantification of the amount of melanin. There are systems for light, so spectrometers are in use for that, to quantify the amount of melanin, or during, for example, the traditional thermal interaction treatments to detect the temperature of the surface and to avoid problems there. There are already these kind of cameras, but obviously the cost and the dimension of such a system become fundamental not to go in the mainstream market, even if it's in the professional market.
Okay. Furthermore, there were a lot of other companies who I thought would be great if you could do some business with, Luca. And this company is in Lithuania. Sergey from Astrum LT, one of our OEM solution providers in medical laser demand. Sergey, what do you have in mind?
Yeah, hi everyone. Hi Jose, hi Luca. Thank you for the presentation, Luca. Just a couple of words. The company I work for is Astrum, and we focus on design, development, and production of laser systems, OEM laser systems, exactly for cosmetology, dermatology, and surgery from recently. The only thing that I'd like to emphasize that we do only diode pumping. So we use all our solutions as semiconductor solutions. So my question was initially, in your high power applications, meaning 1 joule or joule and more in nanosecond pulsing for tattoo removal, for example, do you use flash lamp or semiconductor technology? And if you do only flash lamp, what does prevent you from using diode pumping or semiconductor technology?
Honestly, it's just the cost. So we have to use the most economical way to have the highest power. And the flash lamp pumped solid state technology at the moment is the best. It's true that needs maintenance, but is true that we consider the cost of the pumping diodes typically is not competitive. When probably in the future will be, we hope so. But at the moment, we can also deliver almost 1 joule in half of a nanosecond with about 2 gigawatts of peak power. But to get this kind of performances with a non-flash lamp pump technology is hard, for cost reasons.
Okay,
no, this kind of mix. Sorry, go ahead.
Why I'm bringing this, not just about the cost. What we think about diode, there is an advantage about it. One of the systems that we approached the market a couple of years ago is that allows one system to give nanosecond, microsecond, and long pulse at the same time in the same machine in one optical system.
Now, you know that
which you cannot do with the flash lamp. Yeah.
No, you can. You can. You can. Yeah.
Oh,
you
okay.
can. It's true that the free running of a switch is microsecond, but if you make properly the I can say the reflector, the reflector can resist even in a millisecond range.
Yeah, we offer not just the free running, but CW up to 60 milliseconds.
Okay.
Sergey, you're going to have a fantastic follow-up discussion. But I really also want to find another potential partner for Quanta. We want to talk, when I saw this slide, I loved it. And then I thought, okay, let's talk a little bit about holographic optics. So I have actually an EPIC member all the way in Israel, Karen. I think there is a chance here to find something beautiful out of this meeting. Karen, you are our EPIC member in DOEs. So tell us what you could do with Quanta, and then we'll ask Luca if that's interesting.
Well, actually, thank you, Jose. Holo and Quanta are well familiar, and I think that Luca knows our technology, but I will very briefly discuss it and share for the rest of the people. So just let me know if you see my slides.
Crystal clear.
Okay, great. So just very briefly, Holo was established some 30 years ago. We were the first in the field to commercialize diffractive optics. And a little bit about what you can do with diffractive optics is, I'm going to show you if this will move forward. Sorry.
Try the space bar, normally works.
Yeah, okay. So these are the basic shapes that you can generate from using diffractive optics with lasers. So it's really, if going back to Alexei's question about the illumination pattern, this is something that diffractive optics can be used in order to modify. So we can split the beam into multiple beams with identical or similar characteristics that can be controlled. You can shape the beam on the focus line, and you can also change the focal shaping of the beam. And one specific thing that I wanted to talk about today very briefly is our new polymer on glass product family, which is really an economical solution for mid-power systems. Typically in high power systems, what we do is we manufacture on fused silica, but for mid-power systems and low-power systems, we started working on this polymer on glass option, which has relatively high laser damage threshold. We tested it at 10 joule per centimeter square regime at 8 nanosecond pulses at 1064. it has all the angle tolerances. This specific element that you see here is a refractive element, but we can also do it with diffractives. And it really can generate new possibilities for other applications than the very high powers ones that are already done on fused silica. So
we have already the offer. Let's go to the demand. I want to hear from Luca. Is there anything here that we can help you when it comes to holographic optics?
No, yes, we are already cooperating. We buy probably hundreds, really, or almost, anyway, hundreds of optics like this, which are pretty expensive. I can say to Holo is a nice cooperation. We started 4 or 5 years ago, something like that. And one of the, I can say, the highest limits of the diffractive technology is that it's working just for a single wavelength. No, so we have to replace, we have to change these optics for different wavelengths. But I know that probably Holo is also developing a dual wavelength element, yes, which is for sure more simple, not to be used for the operators. They don't need to replace the hologram at each wavelength. This is one of the important points.
So actually,
we are asking not to try to improve on this side.
So actually, if I can just comment on that, first of all, we have some elements that can work with multiple wavelengths, depending on the harmonies of, I mean, if you're using the same laser, we can work with different harmonies on the same element. So that's one option. And another option is specifically the element that you saw in my presentation. That's a refractive element. That's a broadband diffuser. We don't have that for multispots, but we do have that for diffusers. And it works with any wavelength in, I think, between UV to near IR.
There's an obvious room for cooperation here. Luca,
So
if there is anything, because I know you cannot share much, but if there is any concern, I know there are many, about the need for optics and micro-optics in any shape and form with any coating, share this with us, because Epic has excelled in helping companies in your segment on this. But I want to go now, we covered everything apart from the fiber. I want to find fibers for Luca. And for that, I want to start with one of our key companies that we have in Epic on the field of specialty fiber, in Epic and in the world. OFS. Udo Fetzer is here with us. Udo, thank you very much for being our final or last speaker. Tell us what you can do for the others, what the others can do for you, and let's do business on a Monday afternoon. The floor and the attention of everyone goes to Udo Fetzer, goes to OFS.
So we go to OFS, but we go in slightly different direction. We go to Steve Allen.
The best hair in the Epic network belongs to Steve Allen, all the way from the US, being the person of Epic for the specialty fiber world. Steve, the floor and the attention of everyone goes to you.
The hair is the result of the pandemic, of course. So, but that will end soon. I'm going to get my hair cut shortly. So I did have a question for Luca as well, but you can think about it. As I go through the slides, we have 5 minutes left, so I'll try to go as quickly as possible. Did you lose my screen?
Not yet, we didn't get it.
Oh. Okay.
Bottom of the Zoom window, arrow up. Yeah, you know the drill. 2021. Yes, fantastic now.
Okay, so with all the articulating arms that we saw on the different platforms, Luca, does Quanta have an initiative to try to, or an effort to try to replace those with fiber? So you can think about that. And I know there's a lot of challenges. So OFS, real quick, OFS does a lot of many different things, but for the medical industry, one key advantage is that we are vertically integrated. We make the glass, we make the fiber, we go all the way to the cable, and all the way to the assembly component that goes into a medical device. We do a lot of different things in the medical industry, and specifically for cosmetic surgery. Remember, cosmetic surgery was one of the first segments in medical that drove the adoption of light with all of the things that we're talking about. And I heard OCT, I heard skin treatment, I heard tattoo removal, and we do all of those things. This is an example of a fiber that goes in the dermis to do ablation and reduce this picture over here, reduce cellulite, if you will, by eliminating the fibrous tissues that connect to the top layer of the skin. Crazy stuff. Hair removal, tattoo removal, all the way inside the body for leg vein treatment, eliminating varicose veins or spider veins. Lots of stuff. We developed a fiber that can specifically handle tight bend radius. So under power, tight bend radius without failure, which is a critical thing you need to have. We do a lot of different tips and shapes. If you wanted a side fire, a confocal fire, a radial fire, all different kinds, straight fire, lots of different things, even into the light source itself. One of the recent modules that we brought to market is gaining some traction in the medical industry, and that is our Raman module. From fiber on a spool with the TFB that can receive the laser photodiode power into the light source. But this is a Raman module. So on that cart, if you will, the advantage giving you a selection of different wavelengths, all the way up to 1900, and it's been looked at to replace or compete with maybe thulium wavelengths as well. So the epic question, what does OFS do or can do for for medical device manufacturers? And Luca touched on it as well. We have low bioburden assembly rooms. We follow FDA good manufacturing practices and all of the regulatory approvals that Quanta was mentioning. We do biocompatibility, and we are ISO certified, not just 9001, but 13485, which also mirror FDA good manufacturing practices. It's clear to note that we do not go after the regulatory approval. We reserve that right for the medical device company. But with all of this, it helps extremely with the components already being certified. That's what I have. Jose,
thank you very much for this. I want to go back to Luca now. So this is the cooperation business. Luca, all the way from Quanta, tell us about something, a wish list for specialty fibers. And is there some cooperation here?
Oh, yes, we have also a fiber production. So we are not making the fiber, the core of the fiber. No, so we are assembling the fiber. We are doing a good numbers with that. So it's always interesting for us to talk with who can maybe supply this. So replacing the fiber, the articulated arm with a fiber, I don't know if this is possible. So because the kind of peak power we have to deliver is hard. No, in case of a CO2 laser, this could be also a possibility if you have fibers that can deliver this well. No, not all of fibers, because these are losing the possibility. With this, we lose the possibility to focalize as we need. And so from this point of view, good. So we also ask for different core shapes. We are using also square fibers, not only round fibers. So it's one of the way we can play with, not to make it, to offer a product that is answering better to the needs of the market. So we can for sure talk about what we have.
Steve, I'm seeing a lot of emphasis on companies like OFS developing fiber for endoscopy. Is that a market that you are addressing? Is there any specialty fiber that you're pushing towards that market?
Well, we do. Yes, we do. We make a lot of different probes that go inside the body for a lot of different things, for power delivery, for imaging, for OCT, for urology, so yes, you name it. One of the fibers I showed on the slide does address that as well. Again, meeting that requirement to not fail under power, under a tight bend radius, specifically many times going into the kidneys or something like that. So yes, we do the shaped fibers, we do the square, we have hollow fibers as well in other markets and all kinds of.
You have a lot of fiber, of course. I have a question from the end user side, Colgate. Hrebesh, what's on your mind? I have a favorite Epic end user today. Well, L'Oreal and Colgate both were my favorite people. I'm gonna send you Max with the 700 members. Please unmute yourself.
Yeah.
That's great. Thanks a lot.
Hi, Steve. I'm just wondering whether you have any off-the-shelf fiber bundle for a probe-based confocal imaging.
Fiber what? Say again?
It's a probe-based confocal imaging of fiber bundles, single mode fiber bundles.
Oh, bundles?
Yeah.
Not off the shelf. No. That would be depending on what you would need. Depending on the fiber bundle you're talking about, some of them are very specialized. Some of them, you have to have a process to put the bundles together. If you're mapping both sides, if you're not the whole thing. So not off the shelf. It would be specific to what you need.
So do you develop, do custom fiber works?
We do custom fiber work, yes.
Okay.
Absolutely. That's one of the advantages of starting with making the glass.
Okay.
For OCT, for example, the lens at the tip of the fiber that gives you the focal distance, we can customize that graded index fiber.
Yeah. And where you are located in the US?
We have facilities all over the world. We have a facility in Brøndby, Denmark that also has recently developed a swept source for OCT and other things. I'm located in Avon, Connecticut in the US, which is between New York and Boston. But we have a facility in Atlanta and Massachusetts.
Okay. Okay, thanks.
Okay. So actually, before we also have Kimo from Oplatech talking about the fiber bundles in silica fibers. I'm gonna make an introduction with Hrebesh, and also yes, I'm gonna send you a Mac like this one to you and to my friends from L'Oreal. I want Benjamin to give the final words. Benjamin from L'Oreal, my hero this afternoon, give us the final words. What do we do now to start working together or continue working together?
Thanks a lot. I think that what we've seen is that we have similar issues with the people you invited today. We work on similar topics, and we face the similar issues, which is to integrate technologies into consumer goods. And well, I think that great ideas were shared today, and we have a few people who already proposed technologies, and we will get in touch.
A lot of great ideas were shared today. A lot of opportunities were presented to cooperate. I really love, because I actually made this slide while I was talking to you, and I saw that we had actually end user perspective and companies in the supply chain looking for partners. It was clear to me that we had spectroscopy and hyperspectral imaging. We have OCT. We have 3D face recognition. We have Colgate looking. They already have the blue LEDs based whitening. They are looking other colors. We have so much room for cooperation. Let's make it happen. You know, the meeting is over, but the most important part of the meeting starts now. Now is with the follow-up starts. If you want to get in touch with any of the participants today, just drop me an email, jose.pozo@epic-azo.com, and we'll make sure that you get introduced. It's also, at the end of the day, it's all about finding this room for cooperation to make things happening. If you want to only attend these meetings and watch them in YouTube, is nice, but you're missing the most important aspect, be in the Zoom room and answer the epic question. And today we had a fantastic set of answers for this epic question. If you want to participate in any of the upcoming meetings, they are all in the website, epic-azo.com. Go to the website, and if you find any meeting in which you can contribute, register as soon as possible to make our life easier. On behalf of a fantastic team of laser expert, technology expert, photonic integrated circuit experts, everyone here at Epic trying to serve you, I would like to say thank you very much for making us the dream of reaching 700 members. But it doesn't matter, it's only a number. What matters is you. And now it's your turn to do the follow-up. Until the next time, wear a mask, wash your hands. I can't wait to start traveling. See you soon. Bye-bye.